Hello, and we're here back at IAGS, and I'm very excited to be chatting to Brian Townley today. Thanks for joining me, Brian. I really wanted to know what got you into geochemistry to begin with.
Yeah, I mean, geochemistry, I started off in geochemistry when I did my PhD at Queen's University in
Oh,
Kingston,
cool.
Ontario, Canada. And
Sweet.
Ian Nicol, he was my geochemistry professor, and
Yep.
learned a lot. I learned a lot. And geochemistry is not something that was taught at the University of Chile. I'm an undergrad and master's MSc from the University of Chile. And of course, applied geochemistry at the University of Chile wasn't strong.
Yeah.
So it was not till I did my PhD at Queen's that I learned about this realm of geochemistry and applied geochemistry. So I use it. It was one of the mainstream tools I use in my PhD thesis, which is exploration of the Chilean Patagonia. So we spent 4 years sampling and running exploration programs in Patagonia. Geochemistry was that prime tool. And later on, it was Peter Rogers, a good old friend, Canadian. He's well known. Some people
Cool.
like him, some don't.
Yeah.
But
I don't think I've ever met him. No.
no, he's quite an interesting person.
Yeah.
And way back then, he was even a lot more interesting. So yeah, I mean, we were friends. Met in late '90s, and he got me involved in the LOC for the 2001 IAGS
Yep.
in Santiago.
Yep.
So that was like my first touch with the AAG. And right after that conference, we organized a very successful conference in Santiago. And right after that, I joined the AAG. I quit the SCG.
There you go.
I quit the SCG.
You went all in for AAG.
Yeah,
Yes.
all for AAG, and I've been AAG member ever since then.
Yeah, nice.
So and I've missed a couple of the conferences, but I've been to most of them since 2001. So actually,
Awesome.
I counted them. I've been to 11.
Awesome. That's really cool.
Yeah.
Oh,
And
brilliant.
I mean, I teach applied geochemistry at university.
Yep.
So and I do have a fair number of students, at least 10 or 20 per year.
Yep.
So there's professional geochemists, geologists, geochemists, and I'm also doing diploma courses. I also use a lot of geochemistry for mining engineers,
Yep.
and a master's program for the Catholic University of the North, which, in Antofagasta.
Yep.
So yeah, I mean, try to promote geochemistry. I've managed to have 1 or 2 student chapters.
Yeah.
Unfortunately, as soon as they graduate, they disband, and it's hard to keep student chapters going.
Yes.
Then again, I think the EAG has great potential to better support student chapters.
Yep.
So I'm still trying to motivate and push students into organizing and becoming members of the AAG.
Yep.
Because it's the only way that we can make sure that we'll continue having good geochemists
Exactly.
in the industry. Geochemistry has been the basic tool in the mining industry ever since we've been mining.
Yeah.
And we just take it for granted. And we take it for granted that any geologist should know about geochemistry, and that's not the fact. A lot of geologists don't even understand the definition of sample.
Yeah. Yeah.
And so yeah, there's a lot of things to teach, and I strive on that. All my research projects involve applied geochemistry. My graduate students, masters, PhDs, I've got them all working on geochemistry.
That's cool. What are some of the main trends that you're seeing for South American interest at like the university level?
Well, right now, for the past 12 years, I've been working in geometallurgy. So it's basically using multi-element geochemistry to characterize alteration types, types intensities. Also, then link that to geometallurgical behaviors to develop predictive geometallurgical models.
Yep.
Which is something that it's not common practice in the industry because since we have very few geomet samples in an ore deposit, we just tend to domain.
Yeah.
Everything is domained, and in the end, we have no sense of spatial variability of, for example, hardness or mineral liberation, net acid consumption, or any other geomet variable, because you just domain it based on lithology or alteration. You're not using your mineral variability and to which nowadays, with all the tools we have a good grasp on a detailed mineral composition
Yep.
of our rocks. So can we do predictive geomet modeling? Yes, we can. So that's one of my mainstreams, and of course that brought me into reprocessing tailings.
Yes.
I mean, basically looking at old tailings that still, I mean, old mine deposits with high copper cutoff grades. So there's still great potential in those tailings. Of course, all the hard work of grinding it is already done.
Yep.
So it's basically mineral separation, mineral concentration, and that again requires good mineral characterization, good geochemical characterization, and then an evaluation of what can be recovered, and then determine if it's economically viable to reprocess and recover everything you can. And of course, when you do that, you're going to wind up realizing that, okay, we can reprocess tailings,
Yep.
but at best, we're going to get 1%, maybe less.
Yep.
Recovered, and you're still going to have a 99% volume problem.
Yeah.
You're going to have a new tailings. So we've also been looking, and this is working in collaboration with other universities, both in Chile and Germany, looking at geopolymer technology. So it's basically using the final clean tailings to develop a product which is similar to concrete, but it has no calcium carbonate. It's calcium carbonate free.
Yep.
So in terms of CO2 footprint, it is at least 80% lower.
Oh, wow.
Yeah.
That's really cool.
And of course, when you consider we're a country that has billions of tons of tailings, if you could actually take that to concrete, you'd have enough concrete to rebuild the entire country again.
Whoa, that is very cool.
Yeah.
So what's the status of that? Like, where's it up to now?
It's quite advanced. Right now, I'm working with colleagues at the Catholic University, Santiago, and they have right now a prototype which can process up to 1 ton per day.
Yep.
So that's a pre-industrial. Now, the interesting thing is that that process, in order to clean the tailings before you can prepare the geopolymer, you have to desulfurize it.
Yeah.
And the desulfurization process, what they're running is an inverse flotation.
Yep.
So basically, you depress the sulfides and take everything else, and usually it's about 10% loss in terms of their residue. And they were asking me, we have this problem, we have this residue, it's hot, it's rich in sulfides, what do we do with it? I just kind of looked at it and just pass it over.
Yeah.
That's where the chalcopyrite is, so I can recover copper, likely the gold, and I bet you there's pyrite, and that pyrite may be cobaltiferous. If it's cobaltiferous, I'm also interested in reprocessing that, so I can get rid of your 10% rubbish.
That is epic.
Yeah.
I love that.
Yeah.
How long have you been working on that for?
That's about a year now, maybe a little over a year. We still haven't gotten, we have a little tailings deposit, it's 300,000 tons, which we want to use as a pilot.
Yep.
So start running that 1 ton a day plant, and hopefully continue upscaling it to about 5,000 tons a month.
Yep.
And start producing the concrete, which again, I mean, one of the key barriers is if we produce geopolymers, they gotta be at a lower cost, lower price than concrete.
Yeah.
If not, it just doesn't compete. And of course, the cement industry is not going to go to something different if it's not cost efficient.
Yes.
So it's the same thing with the mining industry. I mean, anything we develop in terms of technology, science, it's got to be cost effective.
Exactly.
Otherwise, you're not going to cross that barrier into to anything applicable in the industry.
Exactly. Yeah. It's got to not just be a good choice, but very cost effective.
No.
So
in the end, you got to show them show me the money. That's
exactly.
If you don't show them the money, they ain't gonna buy.
No.
So a lot of research is focused on trying to have an early evaluation of all these tools, everything we do, seeing what's necessary, what's not necessary.
Yep.
Because there's a lot of emphasis on mineral characterization, and yes, I can't stress how important it is, but there is a thing as too much.
Yeah.
And when we start getting too much data, it gets hard to process. And when you think of too much data, in the end, you're going to composite anyway.
Yeah.
And you're going to composite to 1 meter, 2 meters, block model, 20 by 20 by 20 meters. So once we composite, it's like, was it necessary to characterize it to a 0.5 millimeter?
Exactly.
The answer is probably yes, but
Yes,
maybe not
but
all of it.
exactly. Yeah.
Maybe not all of it. I mean, I do use mineral characterization, but usually what I do is I use it to calibrate my geochemistry.
Yep.
So and then I use geochemistry as a mineral characterization, as a quantitative mineral characterization tool. And since nowadays pretty much everybody uses multi-element, and you have a multi-element sampling at 1 meter or 2 meter
Yeah.
support, you can have very high resolution models of ore deposits,
Yeah.
and link that into the geomet, link that into basically understanding how we can get better profit out
Yeah.
of a deposit, what minerals we can actually recover in terms of opportunity, just looking at the same processing plant. It's hard to change things in the mining industry, but when you have a processing plant and you start understanding how minerals behave along that processing plant, there's opportunities. There's
Yeah.
many opportunities, minerals that concentrate in certain points of a processing plant that if you don't do it at that point and you let it go to the tailing, it's gone.
Yeah.
Because then reprocessing the tailing is just too expensive.
Yeah.
So we're aiming at hopefully looking at tailings, fresh tailings in the processing plant.
Yep.
And try to basically scavenge everything we can out of those tailings, and desulfurize or depyritize the tailings. So the end product will be an aggregate,
Yep.
which could be used pretty much in
so many different ways.
so many different
Yeah,
ways,
yeah.
as long as it's clean.
Yep. Yep.
And of course, you think, well, what am I going to do with the sulfides? And it's like, give it over. It's full of metals.
Yeah. Exactly.
So
Wow.
yeah. So that's it's been a fun road, and so that's my mainstream. And I do have an additional hobby in
Hey,
applied
okay.
geochemistry, which is geochemistry in the wine industry.
Nice. So you would be loving South Australia
Yeah,
right
oh no,
now.
it's not my first time here in South Australia,
Yeah,
and you've
yeah.
got great wines. And yeah, I mean, I've been working for 10 years now, a little
Yep.
over 10 years with the Wine Consortium of Chile,
Yep.
which consolidates about 70% of the wineries of the wine producers in Chile.
Yep.
And we've been studying terroir, geology and terroir, and
Yep.
basically the influence of site, local site geology, substrate, soil, all the way through the critical zone to the plant, to the grape and to the juice.
Yep.
And we've been able to sort out the influences that that site geology has on specific aspects of wine growing. I mean, a wine production, and of course, there is an influence, and it's site specific.
Right.
So when you link the site specificity respect to certain terroir conditions, if you can actually demonstrate that you are very specific and that nobody can reproduce what you have in your vineyard, you have a terroir. But not only a terroir, you have a terroir which you produce a premium wine. And in the wine industry, having a premium wine makes a hell of a difference.
Yes.
It's orders of magnitude in terms of profit.
Yeah.
Once you have a premium wine which sells over $200 a bottle, the profit in that is just humongous.
Yeah. Wow.
As opposed to common range wine,
yeah.
$20 a bottle.
Did you make your own then, or just focus on the science behind it?
At the moment, we focus on the science behind it.
Yep.
I had a PhD student. She finished in 2020, and I'm still working with one of the largest wine companies in Chile, which is Conchedoro. And so I have undergrad students. Trying to bring in a postdoc. And of course, looking for funds. It's a larger challenge or a bigger challenge than the mining industry, because the wine industry is not particularly profitable.
Yeah.
So of course their resources
A bit more limited.
yeah, they're highly controlled, and getting funding from them for research is not easy.
Right.
Now we do have access to public funding,
Mm-hmm.
so I leverage whatever I can get from the wine industry. We leverage funds from public funding, and I'm trying to bring geologists into the line of applications into the world of agriculture.
Yeah.
It's not only wine. This could be applied to olive oil, to any type of
a lot of grown things.
a lot of different types of productions in terms of quality. So yeah, I mean, trying to bring in the geology into the agro industry.
Yeah.
Now, of course, when I do that with my students, I explain to them early on, it's like, this does not pay what
Yeah.
the mining industry
Yeah,
pays.
yeah, yeah.
But then again, I mean, there's so many geologists coming out of the universities in Chile right now that having another area of development for geologists has been good.
That's unreal to hear that you are experiencing a lot of geologists coming out of
Oh
university.
yeah.
Yeah.
Yeah. Right
Yeah.
now, it's 12 universities in Chile that are teaching geology.
That's incredible.
Yeah.
That's awesome.
So I'd say we'd have at least maybe 100 or more coming out to the market every year.
Wow.
And that's putting a lot of stress in the market, and a lot of them. I mean, some of my students, after graduating, they won't find a job for at least a year and a half after they graduate. So
It's crazy what a difference it is between Australia and Chile then.
Mhm.
Like, yeah, we're going through like the opposite. We're going to
yeah,
need them.
yeah,
So,
you're
yeah,
lacking geoscience students.
exactly. Yeah.
Yeah, we
My
had that problem
gosh.
with the mining engineers.
Yeah.
Having students study mining engineering is not easy. But we've been fortunate enough. We have a new generation of academics, and we've been able to motivate in our
Yeah.
faculty students coming into the Department of Mine Engineering. We're up to about 20 to 30 per generation now.
Yep.
So it's a healthy number.
That's cool.
We don't want to get too big.
No, I love that. That's
Yeah,
amazing.
and mining engineers. I mean, there's a lot more opportunities
Yeah.
coming out into the market.
Yeah.
And then again, there's like only 4 or 5 departments in Chile that teach mining engineering.
Yeah.
And there's very few worldwide. So mining engineering is also among those areas. I partly work in the Department of Mine Engineering as well.
Yeah. That's brilliant.
Mm-hmm.
I have a quiz for you today.
Yeah. Oh, okay.
Yes.
Oh, shoot. Cobalt, I bet you.
I know I'm trying to go easy on everyone because it's quite challenging, especially when you don't have a reference point. But I'm curious, what about 33?
Hmm?
33.
33.
Yes.
Oh, geez. I would have to have one of those in my hand, too. But you're somewhere close to cobalt and iron.
It is close to iron. It is.
Yep.
Okay, what about 28? It's
Oh.
getting very close.
28.
Very close to cobalt and
That's very
iron.
close to cobalt. Not manganese.
No, that's the other side.
That's the other side. Yeah. Geez. Nope. Not really.
Nickel.
Oh, nickel. Okay.
Yes.
There you go. Yeah, that's right. Yeah.
But no, this has been really fun. Thank
Mhm.
you for filling me in on everything. And yeah, I hope you enjoy the rest of your
Yeah,
time
well,
here. And
Thank you for having me here, and
It's
it's
gonna be brilliant.
been a pleasure to share.
yes, thank you so much.
Okay. Cheers.
Awesome.